Let me hit you with a hard reality most beginners ignore. Buildings don't collapse because beams were weak. They collapse because the soil couldn't handle the load. If you don't understand bearing capacity and foundation engineering, you're designing blindly. Today, I'll break down the exact concepts that decide whether a structure stands safely for 100 years or fails in a single season. 1. What bearing capacity actually means. Bearing capacity is the maximum load the soil can safely carry without excessive settlement, shear failure, tilting, cracking in the superstructure. In simple terms, how much load the ground can take before saying enough. This is one of the most important parameters in all of civil engineering and a top exam subject worldwide. 2. Shallow foundations. When soil near the surface is strong enough, shallow foundations rest close to the ground surface. Types: isolated footing, combined footing, strip footing, raft foundation. Use when soil near the surface has good bearing capacity, loads are moderate, structures are lightweight to medium weight. Why it matters. Most residential, commercial, and low-rise buildings use shallow foundations. Even a small mistake in size, depth, or reinforcement can cause long-term settlement and structural cracks. 3. Deep foundations. When you can't trust the top soil. Deep foundations are used when the surface soil is weak, compressible, or inconsistent. Types: piles, drilled shafts, caissons, pier foundations. Use when high-rise buildings, bridges, heavy industrial structures, waterlogged or clayey soil. Core idea: you bypass the weak upper layers and transfer loads to deeper, stronger strata. 4. Settlement, the silent enemy. Even if the soil doesn't fail, it can still settle. Types of settlement: immediate settlement, consolidation settlement, differential settlement, the most dangerous. Why settlement destroys structures: cracking walls, jammed doors and windows, tilted floors, misaligned columns, water leakage, structural instability over time. Exam questions almost always test settlement because it connects geotechnical theory with real-world design. 5. N-value, SPT, the most popular field test in the world. The standard penetration test, SPT, gives the famous N-value, the number of hammer blows required to drive the sampler 30 centimeters into the soil. Why it matters: used to estimate bearing capacity, used to design foundations, used to classify soil, used to check liquefaction potential, used in almost every site investigation report. If you understand N-values, you understand how actual soil data drives foundation decisions. 6. Why this topic matters for every student. Bearing capacity and foundation engineering are core exam topics, essential in interviews, required in every real project, directly linked to safety. And on YouTube, foundation-related videos always get strong retention because students finally understand why buildings fail, not just how to design them. That's your clean, no-nonsense breakdown of bearing capacity and foundation engineering. Shallow versus deep foundations, settlement, and N-value. Master these, and you'll understand the ground beneath every structure you ever design. In the next lecture, we'll dive deeper into shear strength and failure planes, the true behavior of soil under load. Keep watching. Keep growing.